Hey, what's up guys, my name is Cherno. Welcome back to my game engine series. So last time we began our 2D physics journey. Check out that video if you haven't already. It's a pretty long one, but there's a lot of good content I think in there. I've tried to condense it as much as possible, and that's kind of the plan from here on out. Point is though, we are on this kind of 2D physics journey, and that's kind of our overall goal now, to get 2D physics to the point where it basically it's fully implemented, everything works, all that stuff. But to get there, the next kind of roadblock that we have is the fact that we need to be able to hit play to play our scene. And then obviously when we hit stop, we want it to kind of reset. So what actually needs to happen is we need to be able to create like a runtime version of our scene that is like completely mutable, meaning it's completely changeable. You know, there's no kind of state there that we need to worry about resetting. It has to have its own separate kind of memory ultimately and state. But then when we hit stop, we want to kind of go back to that like editor scene, right? The scene that we were editing, the scene like as it appears without any kind of disruptions, without any runtime modifications, meaning like we haven't hit play yet, so there's no simulation. Everything is as we authored it in the editor. That is kind of like, that's our next kind of step here. That's our next goal, because obviously since the last episode, if you remember, when we hit play, you know, everything fell and then we hit stop and then the objects remained in that place, because really by hitting play, we just say physics go, start simulating. So then it changes everything. And then obviously nothing kind of reverts that or resets it back to its kind of serialized state. So that is basically where we are at right now. That's our next kind of goal. So to get there though, there are a few things that need to be done. Now, as I mentioned last time, and this kind of applies from here on out, we are fully live streaming pretty much all of the development of this Hazel 2D engine that we're working on twitch.tv/thecherno, right? So everything is always live streamed every single Thursday there. There's a link in the description so you can catch that stream. And if you actually watch that VOD, there's actually two, I streamed twice yesterday. I streamed like in the morning and then I had to go and then streamed later as well. But the point is we got basically all of this working. So if you want to peek ahead, then feel free to actually go through that and see how it was done. But what we're going to do is obviously these videos are going to kind of take everything step by step. So in order to do like the play thing that I mentioned and to actually be able to like revert scenes and, you know, properly handle runtime scenes, we actually need to implement something else. And that's what today is going to be about. Today is going to be about universally unique identifiers or globally unique identifiers, UUIDs, GUIDs, whatever you want to call them. It's finally time for us to actually implement this in our game engine because we haven't had this yet. And as you'll see, it's going to become a little bit of a problem when we want to kind of make sure that, you know, editor entities and runtime entities are kind of the same. Now, I do want to quickly note though, that if you are like, if I boot up Hazel here, this is where we left off. Quick little side note as well, keep in mind we are currently on the physics branch. The dev branch is everything that goes on during the live stream. So in other words, the stuff that we've actively worked on and that I've kind of committed, everything that I've done, basically all the code that I wrote during that live stream yesterday has been pushed to dev. But officially, you know, if you want to keep up with the videos, these videos on YouTube, they're on the physics branch. So just keep an eye out on that. So as I was saying, if we boot up Hazel at the moment and we hit play, obviously this bounces around and we hit stop. If we want to reset the scene, one thing we could do as like a really easy quick fix is just load the scene again. Right? Because if you deserialize it again from disk, assuming you haven't hit, you know, Control S now, actually Control S doesn't even work. We'll address that a little bit later. We're going to have like a kind of maintenance episode where we just do a lot of, you know, low hanging fruit, kind of easy tasks that aren't going to take us much time and aren't worth putting into a separate episode. But anyway, the point is, as long as you don't like overwrite your save, right, your saved scene, if you deserialize it again, of course, you're going to go back to the original scene. That's like a little quick fix of doing it, but we don't really want to do that because obviously we might be like working and stuff like that. So instead, what we usually want to do, and we'll talk about that more probably in the next episode, is we want to actually spin off a new scene. So we need the ability to copy scenes. We want to have this kind of editor scene, and then for runtime, we need to create like a new runtime scene that's capable of doing stuff. It's going to be a temporary kind of scene that we create like while our actual game is in the play state, and it basically gets deleted as soon as we hit stop, right? So in order to do that though, as I mentioned, we need to talk about universally unique identifiers. So when it comes to UUIDs, right, and that's what I kind of want to talk about today, because there's a lot that you could say about it, and I don't really want to go too in depth into everything that they're used for, but basically this is the point of them, right? So we need a way to identify a lot of unique objects throughout our game engine. Now this can refer to entities. So when we create a new entity, in the editor, that needs to be identifiable in a unique way, meaning we can't have the same name on another entity, right? That ID has to be unique between entities. Now, what about things like scenes? Scenes are also important, right? What if you have two scenes with the same name? Well, again, you need to be able to uniquely identify scenes. What about assets? How do we know which texture is which? How do we know which 3D model, if this was a 3D engine, is which, right? There's all of these different things like a sound file, right? Anything basically that exists in the engine needs some kind of identifier. So again, the reason we don't usually use names for this is because it's very possible to have two entities that are called the same thing. And I don't really necessarily want to place that restriction that every time you create an entity, you have to make a unique name for it. That's a bit weird. Even if you did have the engine automate that process, meaning if you tried to call something box, it would call it box2. That's still obviously just weird. You don't want to think about that. A name should not be the thing that uniquely identifies the object, right? Assets, another great example. Assets by file path. There's a lot. We'll talk more about this when we get to the asset manager, asset system videos, but we don't really want to identify assets by their file path for a number of reasons, right? Not only because they might get packaged and zipped and compressed and the path might change entirely and we might have to be dealing with virtual paths, but also because if we update an asset or we want to move it somewhere else, we want to be able to identify it in a way that doesn't concretely tie it to a specific file path, because that shouldn't be the thing that, is kind of not flexible, immutable, and stays the same, right? File paths should be flexible. Anyway, so that being said, right, instead of using all of those kind of systems like names and file paths, instead we use universally unique identifiers. So what they typically are, right? Oh, and the biggest question I think that a lot of people usually have is why do we need this weird kind of UUID GUID system that's if we were to type it out, we'd have an ID of that, right? Why does it have to be this? Why can't I just start it at 0 and every time I create a new entity or a new asset, I increment this? Well, you could do that, right? There's nothing too terrible with that in a local sense. But the reason why we usually generate a random number like this is because consider this scenario, right? What if you are working on your scene and creating entities, and then someone else on their own computer is working on the same game as you, right? Because games aren't usually built by one person on one computer, although of course they can be, right? What if they also create new entities? Well then, who's handing out the IDs? There has to be some kind of authority, like a server or something, that makes sure that you can't both create entities at the same time, right? Because again, if you're just incrementing it, then locally you're going to create 5 entities, you'll have ID 5, 6, 7, 8 taken up, but then someone else on their computer is also going to create 4 entities, and they're going to occupy IDs 5, 6, 7, 8. And then when you go to merge the scene together, nothing makes sense, right? Even if it's in a different scene, right? It could be an asset that's used in both scenes. Well, again, you have the problem of if there's no authority checking this, then we'll have a conflict basically if we just increment. Now, of course, as I mentioned, you could have a server that dishes out an ID, you request an ID from the server, and then it's okay, you asked first, I'll give you 6, and this other guy's getting 7 instead to avoid conflicts. We don't want to set up a server to issue IDs, right? That does work in some scenarios and it is used in some scenarios, but usually we don't want to do that. Instead, if we generate this very random number that is at least long enough, right? Then the possibility throughout a development cycle of a game, right, for me, and then the person working behind me, right, to generate the same exact number, it's just not going to happen, right? The possibility for a conflict is very low. It's still possible, right, but it's very low. So hopefully that kind of answers the questions of why we need UUIDs, right? We refer to them as UUIDs. UUIDs, and we'll talk a little bit more about the implementation in a minute, but UUIDs, GUIDs, they basically mean the same thing. And again, that's why they're kind of called universally unique or globally unique, because they're so unique, to the point where it's fine for you to generate one, it's fine for someone else to generate one. You can generate multiple at the same time. They can be across different computers. There doesn't have to be an authority because it's so kind of random, right? It's so unlikely for you to generate the same number as someone else that it's totally fine to not necessarily use some kind of authority, right? And again, it is basically guaranteed to in fact be a unique number. So that's basically all it is, right? It's our quest to generate a unique number so that we can identify something inside our game engine. So hopefully that kind of explanation makes sense. And hopefully you now also see why we can't just increment a number like 0, 1, 2, 3, 4 and use that as the ID, like ent does actually. Entity, the kind of library that we're using for the entity component system, that does have IDs like 0, 1, 2, 3. It's not really meant to be used over like multiple computers or anything, but again, and that's also subject to change, right? As in, like, if you were to recreate all of the entities again, you'd get different IDs because it's a bit weird. Like it's not weird, but it's just like, it's not meant to be like an identifier for a particular entity. An entity is just like an index into a set of components, basically. So anyway, that hopefully makes sense. Let's dive in and take a look at how we're going to create this. By the way, I want to quickly point out also that we basically have already made room for this stuff, which is really nice. I was very happy when I discovered this during the live stream yesterday. Like, we already have, uint64t here, UUID equals entity as UUID, so we're deserializing here. And I think we also have the other part of this. I think it might be marked with like a to-do. Yeah, here it is. Entity ID goes here, and we have this like random value here, right? So we've already kind of prepared it, which is nice. That's where we're going to store entity IDs here. But again, this is something that's going to exist across like not just like the entity component system and for entities and a way for us to identify entities, right? But it's also going to serve the asset system and like the scene system and a lot of different things, basically. Okay, so the first thing I want to do is if we pop into Hazel, I'm just going to mark this as like the show all files mode so that we can actually like see the folder structure, because I want to make sure that I make this in the core folder. And I'm going to call this UUID because again, it is going to be something that's obviously very core to the engine. And this class, so namespace Hazel, we'll make it a class, we'll call it UUID. So okay, so the implementation of a UUID, we need to talk about what it is at its core. And basically in Hazel, what I'm going to do is, for now, I'm going to make it a uint64t, and this is going to be like the actual UUID. Now, a UUID or a GUID, like traditionally, is supposed to be a 128-bit value. Why? That's just usually how it's defined. If we want to create a 128-bit value, we have a few options. Of course, we could compose it from 264-bit values and then generate it using like a random number generator or something like that. Typically, random number generators in the C++ standard library, as far as I'm aware, only go up to 64 bits. So if you generated two and combine them, like, you wouldn't get the best kind of behavior, we'll say. It's usually not the best way to do things. Every platform usually has a way to generate an actual UUID for you. So if you actually want a 128-bit value, then I think like Windows has something like create GUID, or like, I don't know, there's a Win32 API function that will create that for you. So that's one route you could absolutely take. Here on the Cherno show, we like to not complicate things too much. And like in my experience, a 64-bit random kind of UUID for the purposes of a game engine, and for our purposes so far, has been enough, right? In using this for like over a year and working on projects across different computers of like in using Hazel 3D, using the big Hazel, I've never had anything like close to a conflict, right? Like it's just to generate two identical random 64-bit numbers, that's very unlikely, right? It is still possible if you have millions of entities and tens of millions, hundreds of millions of entities, right? And that's why like it's important to consider the fact that if UUIDs if you picture assets, if you picture entities that you create yourself, well, again, it's probably not something that you'll ever exceed, right? You'll probably never get to the point where it becomes likely or even slightly possible to get a collision. But if you have made an application in Hazel that inside the script, creates just millions of entities per frame, right? And assuming the ECS can keep up with that and everything, of course, you may run into a collision if programmatically you're dishing out that many UUIDs like per second or whatever. So, I'm not going to say that it's completely nothing to worry about, but for now, this is how we're going to treat it. Now, we're going to end up storing UUIDs in maps, which means we basically need to hash them. So I'm going to include xhash instead of trying to include like stdint.h to get this to not be an error, because we are going to have to hash them. And we'll talk about that in a minute. It's obviously very easy to hash this because it's just a uint64t. So how do we create them and what's the API going to be like? Well, the way the API is going to work is just by running the constructor, it's going to automatically generate a UUID. Right, that's kind of the way that I've designed the API. So in other words, if you just write codes such as UUID ID like that, it's gonna give you an ID, right? If you want 0, you can explicitly write 0 for something that is deliberately marked as not initialized or something like that. So that's kind of how we're going to do it. And then, yeah, you can take in like an ID or something like that if you really want to, right? So this can be like your UUID. You know, copy constructors. I don't even know why I kind of entertained the idea of having a copy constructor here. I've got some like sample code that I read during the stream. But basically, if you wanted to, you could make it kind of deliberately a copy constructor. But again, all that's going to do is shallow copy this because that's all we really need to do to copy it. So that's basically our UUID class, right? So how are we going to generate this random number? Well, we're going to use C++'s random number generators, right? So let's include UUID, namespace Hazel, and let's take a look at this. So basically, I think this is all inside random. I'm not 100% sure, but I think it is all in here. So basically, if we go back and we implement like the stuff that we needed to implement, the method implementations here, then obviously our goal here is to just generate a UUID and then store it. So how are we going to do that? Well, we're going to use a couple of things, as I mentioned, from the C++ standard library. We're going to mark them as static, right? We'll talk about this stuff in a minute, but basically we're going to use something called random device, and I'll explain this once I type it out. Then we're going to use this engine that C++ comes with, which is called MT1937, but we're going to use the _64 version because otherwise we'll get a 32-bit random value, which is of course useless to us. So I wouldn't recommend 32-bit UUIDs. That actually, you know, having 4.6 or 4.3, I've forgotten. What's 2 to the power of 32? Anyway, having like 4 billion-ish random IDs is not much, because again, it's not that we need 4 billion IDs, it's that we want to reduce the possibility of generating 2 IDs that are the same across like computers and everything, right? So this is going to be, you know, we'll call this engine, and then we're going to take an sRandom device with the call operator over here to initialize that. Again, this is all going to be initialized statically. I don't really need to care about this too much. And then we'll use this uniform int distribution. This is going to be the thing, UN64T, that actually distributes. I'll call this S uniform distribution. This is going to be the thing that actually distributes, well, gets us the random value. So let's talk about this a little bit. Well, this is just the way that you generate random numbers in C++. There's not much to it. If you want to dive into it a little bit more and see what's going on, you can see that it's using the Mersenne, I don't know how to pronounce that, twister engine, right? So that's specifically what it's doing. And again, you can look into it a little bit more. I'm not an expert on random number generation. This seems to be pretty good, as in my experience. And again, the most important thing is that you are using the 64-bit version because we have a 64-bit GUID, right? So that's important. So how do we generate a random number? Well, it's super easy. In fact, we can just do it up here. So we're going to set this to be S uniform distribution, and then we pass in the engine, right? Which obviously is S_engine, and that's it. So few issues with this, right? Well, okay, there's 2 issues I just want to mention because I did this again on, oh, my computer turned on. I hate it when computers turn on randomly, you know? It really, I started like shutting the PSU off on my main computer like overnight because it would just wake up sometimes. Anyway, so excuse this guy behind me. Maybe I need to turn him off. Anyway, whatever, sorry. So, again, because I live stream this and I plan all this code during live streams, it's actually pretty good because I kind of have a list of questions that people ask that I'm going to convey to you now if you don't want to watch that whole stream. But basically, one of the things that people said were, okay, so what if you did have something to prevent collision though? Again, it's really unlikely, but what if you did have something to prevent collision? And someone suggested having like a hash map. So having like an unordered map. I mean, I guess you could just have an unordered set, right? If you had an unordered set of UUID or UN64T, same thing, right? If you had an unordered set of all this, of all these hashes that you, well, not hashes, but of all these IDs that you gave out, right? Couldn't you just quickly generate it and then basically validate it to be like, well, if I can find that ID in here, then maybe try again? I wouldn't recommend doing this. There's a couple of reasons. First of all, it will obviously add like a little layer of complexity and some more kind of performance cost to generating UUIDs. Not that we care about that too much. Predominantly, the reason I wouldn't do this is because I think the risk of a collision is low enough that we don't need this system. And furthermore, clearly this is local, right? Meaning that if someone else generates a UUID behind me, again, I always keep using this example, but whatever. If someone generates a UUID on my same project on a different computer, this is going to do nothing, right? So in other words, like, it's not really a solution. So I wouldn't bother with any of that complexity, right? The other thing was threading, right? What about, is this thread safe? I don't actually know if this library itself is thread safe. You could make thread local versions of these if you wanted to. The reason why I'm not bothering with that at the moment, I mean, first of all, we don't have threads anyway here. We don't, like, what's a thread, right? Hazel 2D doesn't care about that at the moment yet. It will move to like a render thread kind of architecture later. But at the moment it doesn't, so it doesn't care, right? But the bigger thing is, I don't think that any other thread except for the main thread will ever be responsible for dishing out UUIDs, right? I think that's going to be only called from the main thread, right? And so because of that, I'm not going to bother with that. Like, the render thread is not going to be doing it. It's possible that some, you know, if we offload resources, like resource loading to a different thread, and then maybe the asset manager has to generate a UUID, it's possible that it does that through the resource thread or some kind of job thread, right? In that case, we will need to think about it. But yeah, anyway, welcome to the Game Engine series, the show where we write 5 lines of code and then talk about everything possibly that can happen in the future, right? Ridiculous. Anyway, whatever. I mean, I'm happy with this, guys. Just let me know what you think, because this series, like, I don't know, I've given up on this series. I've given up on this series in the sense that it is just going to be as complex as it gets. It's going to be these episodes are going to be as long as they get. I don't care, right? It's just, my job is to kind of give you guys as much information. You guys seem to enjoy me talking about what's in my head and explaining it to you. So that's just where we are, okay? Now, next step is, again, as I mentioned, it'd be nice to use these UUIDs in like unordered maps and in unordered sets, right? So in other words, we need a hash function to be able to hash this. Now, guess what? A UUID, what is it? It's literally 64 bits and it's an integer, right? Very hashable. C++ doesn't know that though. So what we have to do is actually provide a hash function. Now, it's very easy to provide a hash function. And again, if you're still a little bit confused as to why we even need this, then I'll show you why, right? This might be a little tutorial on how to write a hash function as well. Unordered map is probably something that you're more familiar with than unordered set. But if we have a static void add to map, let's just say we have a std. I've got a habit of writing static everywhere because I don't like variables to be global. But unordered map, UUID, I don't know, entity or something. We'll just say string map, right? This is not going to work, right? We're not going to be able to say, like, make me a UUID and then assign it to Cherno, right? That's not going to work. Why? Because there's no hash function for this, right? Well, why is UUID undefined though? You for real? Oh, it's because it's in Hazel. Lol. Okay. I don't know why I did this outside of the Hazel namespace, but whatever, right? That's not going to work. It might say that it does, but when we actually try and compile it, no, I didn't include the PCH. I don't know why it says that it does though. It's going to tell us that, and this is a very common error that I get a lot of messages about, attempting to reference a deleted function, and I mean, ultimately it just can't hash it, right? And if you look at it, the point being that it's going to work fine if we just treat this as a uint64t, right? And it's totally reasonable to do that because what we might do is we might make this castable. Let's make that happen real quick. So since the UUID is just a uint64t, what we can actually do is create an operator that will actually allow us to cast that. So I think it's like operator, I don't think we need const or anything, uint64t const return MUUID, right? So this will let us basically it basically tells us that if we want to treat this class as a UUID, so if we want to cast it or even implicitly cast it, it's going to return UUID, right? Because again, it's just a wrapper for this one integer. It's important to understand in C++ and in C that like classes, structs, well, more important in C++ possibly because there's a lot more to classes potentially, but classes in C++, they are just the members, right? Again, if you have a vtable, etc., it's different, but they're just members, right? At the end of the day, this is what the class is, and these functions are just like stored in other space in the binary, right? So point being that we can obviously kind of treat them as their type in this case if it's just a thin wrapper like this. So by doing this, we've kind of solved the hashing problem. This will work, right? Why? This is turning into a C++ tutorial. Anyway, why? Because we can cast this to a UN64T and everything's great, but that's like slightly annoying, right? I want to be able to do that, right? So how do I do that? Well, again, what you need to do is just provide unordered map with a function it can use to hash this, because if it's a key, it doesn't know what a UUID is. It's just some custom class, right? I missed this again, right? It doesn't know what it is. So how is it supposed to hash it so that the unordered map works properly? Same thing with if we just use a map, right? Instead of an unordered map, we would need to implement like the less than operator so that it could actually put it into the right spot in our tree. So because of that, we need to define this kind of hash function that's going to be used. So how do we do that? Well, I'm not going to pretend to remember how to do this because I always have to look this up. But basically, we can just do. You have to do this in the std namespace. We can just type in struct hash Hazel UUID, right? And I'll explain this in a minute. So we're creating a template specialization of a struct, right? And a struct is the same as a class, right? But this is a specialization. So the hash is kind of a template. Oh, go away. The hash is a kind of, hash has a template. It's like a template class defined like this, but this is us specializing it just like we would with a template specialization. We've done template specializations before because we have this annoying pile of trash over here, right? During live streams recently, I was like, why did I add this? This seems like such garbage. But anyway, whatever. We'll get back to that on a different day. So anyway, point being that over here with this hash, this is just our template specialization. We're providing it with a way to do this. And so for that to work, again, this is not my code, it's C++'s standard library code. I'm just writing a specialization for their function. We have to implement this kind of call operator, which is just the kind of parenthesis operator, right? So that when we call hash on this type, right? When we try and hash this type, it's going to return a size t, and that's going to be our hash, right? And so what we could do is, again, if this was a little bit more complicated, like UUID wasn't just a 64-bit thing, then we would just get it to generate one for us, right? And again, I think this has to be a const reference just because, again, this is their function. And then what we could do is now we just return our hashing code. So how do you want to create the hash? How do you want me to hash this value when you pass in a UUID as a key into an unordered map, for example, right? And again, because like a UUID is just a 64-bit value, we don't need to hash it ourselves. The C++ library provides a hash function for the 64-bit integer type, right? And so because of that, we can just run hash, but we can basically just redirect it to another specialization of this hash class. And that's going to be this. And then again, how do we get the hash from there? We just do UN64T, UUID64T, UUID, and that's it, right? That should basically be it. Oh, except we have to call this, right? And then that's the parameter. Okay. So again, we're using the call operator to call this same function, but for UN64T, and that's where we're redirecting this to. So that's how we write a hash function. Again, you just need to create a specialization of this and this for your particular type, and then do whatever code you want to generate a hash for it. A little bit confusing, but this is going to be a good reference point for this. I don't think we've done this in the past. Maybe we have, and this has been a waste of time. But anyway, that's it, right? That is how that's how UUIDs work, and how we can basically use them, and how we can hash them and how we generate them, and hopefully everything you need to know about UUIDs. Okay, cool. So how do we use them now in the engine? Well, what I'm going to do is basically make room for UUIDs inside entity, right? So the idea is, and what we're going to use it for initially, is when I create an entity, I want to give it a handle, right? Like I want to give it this UUID as a unique identifier, as a globally unique identifier for our entity, right? So how do I do that? Well, we basically need a way to obviously store it on the entity. How do we store things in the entity? As a component, right? So we use an ECS, which means that it has to become a component. I'm going to do it as the very first component here. I'm going to call it ID component, and then we're going to give it a UUID, and I'll just call it ID, right? And then I'll copy the same pattern that we've had over here, where we basically have the copy constructor and a default constructor, right? Now we need to include UUID. By the way, a quick thing about includes, I don't like I should probably establish some kind of policy / style guide here, but usually I like to include our code first. The reason being that, well, first of all, you should define some kind of order so that it's not just intertwined, right? But the reason why I like our code first is just in case there's some kind of configuration files that might have like macro definitions or, you know, stuff like that, right? Defines in them, whatever. So that way we can just kind of make sure that they're actually compiled first, right? And then we include the rest of this code so that this code might be affected by that code, if that makes sense, unless there's like a reason why we can't do that. Anyway, so that's how we create an ID component, right? We can now have that. So it's really important now that every time we want to create an entity, we give it a UUID. So how do we do that? Well, we have a create entity function, right? It adds a transform component. All I'm going to do is also get it to add an ID component. Now that's it. That's all we have to do, right? Because by adding an ID component, it's going to call the constructor. That itself is going to generate a UUID for us immediately. Now we'll also need a function called create entity with UUID. And the reason that's going to need to happen is, I'll show you in a minute, right? Is because of the basically deserializing entities. If we want to create entities in the scene that have already been created, like because they're just being deserialized or there's plenty of other reasons, we obviously need to give it a UUID that we will, for example, read in from the actual like deserialization, from the actual kind of YAML file that stores all of our scene data. So let's serialize it first though. How do we serialize an entity? Well, yeah, I'm just thinking about this. No, maybe let's make serialization work, because what I'm going to do is I'm going to deserialize it, get Hazel to generate UUIDs for all the entities in our scene, just randomly, because we're not using them anyway yet, and then serialize it again. The reason being that I don't want it to deserialize this number and then put that in. That's going to be a bit weird. So if we want to get a serialization working, then instead of just using this, I just want to be able to basically ask the entity, hey, what's your ID, right? And we can probably just assert here that if the entity, has component UUID, like if that's not the case, if it doesn't have that, UUID, ID component. If it doesn't have an ID component, then we don't want to serialize it. Like it's probably an error because we're probably trying to serialize some kind of like scene meta entity or something weird, right? Every entity has to have an ID component. Okay, so how do we get it? Well, again, you could do entity get component, ID component dot. This is just so annoying though, right? Getting an entity's UUID is such a trivial task. I want to be able to actually just call get UUID, and then that's going to look up the entity component system. So again, we're using this kind of entity, like entity class as just a wrapper for us, right? A wrapper that will do all of the ECS stuff for us, that will just make our code a little bit simpler. So how do we add that? Well, actually this turned out to be a little bit confusing during the live stream because we actually include scene here, and that led to some problems, and I'll show you why in a minute. Hopefully it will, I mean, it still should lead to problems here. Anyway, so the point is, if I want to write a function called get UUID, right, then what's this going to be? It's going to be get component. Again, we could do it like an assert for has component, but whatever. So get component ID component dot ID, right? That's what it's going to return. This gives us an error, right? Why does this give us an error? Because apparently no. I'm just going to make sure that I did it correctly. I think I did. Anyway, point being that I think, but we're including scene, aren't we? So actually, this probably should work. No function template. Get component ID component. Oh, sorry. That's because I marked this as const for some reason. Yeah, it seems to work. Get UUID unknown. Syntax error. Oh, UUID. Okay, well, yeah, that's fine. That we can include UUID. UUID doesn't include anything, so we can definitely do that. I wonder what was up during the live stream. Because I feel like either we didn't have the scene include or... Yeah, this looks... Oh, here we go. ID... Oh, this is the problem. Sorry. I knew there was a problem. So basically, we have to include components so that we can access specific components like ID component. But unfortunately, components includes scriptable entity, which includes entity. So this becomes a bit of a recursive include. Components includes entity, entity includes components. And obviously, if we try and like Control F7 this, it's not going to work, right? So how do we fix it? Well, we basically look at, like, components shouldn't be including entity, right? A component generally doesn't know about entities. However, you can see scriptable entity is the culprit because scriptable entity includes entity. So what I'm going to do is not include scriptable entity here, right? We use it over here. But what I'm going to do is I'm just going to make a forward declaration for it, because you can see the scriptable entity is just a pointer anyway. So we can just define it like this, right? And then actually include the scriptable entity class when that pointer needs to be used, right? So I'll just do a little forward declaration here. And then I think if we hit compile now, it should work. And then I think in scene, it probably won't work because it doesn't know what it is, but this is where we include it, right? So include scriptable entity. And then it should be okay. We get a static assertion failed because we need to add this pile of garbage. I'm gonna really rethink this system. This was just a way for me to basically have a non-component added function. I don't know why it has to be present though, but whatever. Well, I guess we could have just removed the static assert and it would have just used this and not done anything. Actually, why was this a static assert false? Why can't we just do that? Because clearly it's going to use this if it can, but everything else doesn't need to exist anymore, right? Wouldn't this make more sense and still work? Yeah, I don't know, man. I don't know what past me was thinking. Again, maybe someone who has actually gone through that episode more recently knows why, but whatever. All right, so where are we now? So now what should happen, obviously, is the scene serializer should serialize the correct UUID, and we should in fact have a different UUID for everything now. So if we actually go to Hazelnut into assets, scenes, and into physics 2D, let's say, you can see we have this same UUID everywhere. What I'm gonna do now is launch Hazel. It should generate UUIDs for us, right? Immediately when it deserializes these entities, if we can even get the thing building. Okay, well, this is upset now. So maybe that was, I should have probably tried linking it, not just compiling it. On component added. But why doesn't it just call the, oh, because the template wasn't defined in the header file. That's why. So it actually needs it. Because this, we decided not to define, because I don't think we could define specializations just in CPP files, and we probably didn't want. Okay, yeah, this is annoying. Okay, we'll keep it for now, but this entire system I will rewrite later. Yeah, so in case you didn't follow along, the reason that didn't link is because this isn't defined here. So it actually needs a concrete definition for every type. It can't generate a template in the other Hazelnut module, which is the exe file. Okay, so if we try and load this, right? If we have a quick look at this, so these are the UUIDs, right? But if I save it now, if I overwrite this, so assets, scenes, physics 2D, so if I overwrite it like this, yes, then you can see now, right, every one of these is obviously different. It's unique, right? So I might just go ahead and quickly do this with all the other scenes. Okay, so I've done it to all of the different scenes now. They all should have UUIDs, and now that they have UUIDs, let's actually not regenerate them every time, right? Because obviously if we run it again, what's gonna happen is when we deserialize an entity inside the serializer, so let's find the other to do, it's just still gonna call mscene create entity. What does that do? It generates a new UUID. So we obviously need to make sure that we're actually creating it with a UUID, create entity with UUID. And so we'll take in a UUID, just by value is fine, it's just a 64-bit value. Create implementation. And then we're basically gonna do this, right? It's just that this UUID, when we add when we add this component, right, it's going to be specifically this that we add, right? Let's just make sure that this should be fine, right? Error type. Okay, error type. What UUID is an error type? Okay, let's include UUID. Keep it in alphabetical order. Okay, should be good, right? And then so we'll just change this to be return create entity with UUID. And this is going to be, so we'll generate a UUID in this case, and then we'll pass the name through as well. Okay, so now we're creating it with a specific UUID. And that's it. Then we just change this to create entity with UUID. And obviously we don't really have a way of verifying this, but it should actually not create a different one. So we'll just pass it the UUID that it has retrieved from this YAML file, right? So now we are properly serializing and storing our UUIDs that we generate, okay? That's it. So I'm gonna remove these to-dos, and And I think we're pretty much good to go. I guess we'll validate this. So the way we'll validate it quickly is we'll just make sure that camera is always 47939, like blah, 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 again, right? We could serialize this as hexadecimal, I guess, to maybe save some bytes of text. I don't really care to know. I don't know. I never seem to care about anything, but I just don't care at the moment. Okay, so physics 2D, that's what we were looking at, right? So if we save that and we actually override it again, right? I'm hoping that we have the same one. So it changed position, which is fine, but you can see camera is 47939, right? So it has in fact remained the same. See, that's also why we don't trust ent or entity for any kind of ID stuff. It's not built for that. It doesn't guarantee that. It can change stuff all the time. And that's totally fine. That's actually totally fine. We don't care because we have our own ID system, as we should, for something like this, okay? So now every entity that we create is going to have its own generated UUID, which we should probably display here somewhere. In Hazel, in proper Hazel, if you hover your mouse over the tag, it actually pops up just in case you want to debug it or whatever. But usually that's not really required. Anyway, hope you guys enjoyed this video. If you did, please don't forget to hit the like button, patreon.com/thecherno. I'm forever grateful for all of your lovely support. You'll get access, of course, if you support there, to the big version of Hazel and see all of these concepts already implemented. And your support is what keeps this series going as well. Now that we have laid down this groundwork, next time, we are going to jump in and make it so that when we hit play and stop, it actually reverts our scene properly. We'll set up all of that runtime scene functionality. I'm not going to make you guys wait a week because next Thursday actually is when we are going to keep live streaming and keep working on Hazel. So I'll probably just make another video throughout the week, right? So expect another one in a couple of days or 3 days or something like that. And we should be able to get back on track. Thank you guys for watching. Have a great rest of your day. Goodbye.